This is test ID 33, component ID 80. It is for fuel control O2 sensor big slope. Now component ID 80 indicates we have a minimum limit or specification. This applies to the right or rear O2 sensor when dual fuel control sensors are used. Now the PCM monitors the rate of change in oxygen sensor voltage to calculate the speed of the voltage change known as big slope change. This sounds a little complicated. Let me tell you how we do that. The PCM calculates big slope change by dividing the change in voltage by the change in time. This results in a rate of change. The rate of change is millivolts per millisecond. Now again, one of the things we like to emphasize about Chrysler is we do not get converted values, so we can't go and measure something. We have to use them as relative indicators of what's going on. Remember, the monitor fails when big slope is too low. Here's some typical data. The test value was 94. The minimum limit was 10. As you can see, we easily passed this. But this is not something you can measure with a voltmeter. In fact, we can't measure millivolts per millisecond with anything. But we can measure the sensor's response time with a lab scope and see what's normal and what's slow, and that's what we're going to be doing in order to verify the information here. We're going to take a couple of minutes to look at some scope patterns. Notice that the green arrow is pointing toward the fuel control and the red arrow is pointing toward the after catalyst. Now the first thing we're going to do is to stop this pattern and study it in some detail. The big slope measurement is the difference in time and voltage, like the 2 points you see up there where we're pointing to. Sensor response time is being measured by the big slope, and the PCM is going to do a very specialized test. It's going to do a rapid change in fuel delivery in order to make this measurement. Now we're going to have to duplicate this with our own test. We're going to use a snap acceleration test to produce our rapid changes in fuel delivery. Now we'll stop and take a look here real quick at a signal where we made a quick change. Notice that the green trace goes up fairly quickly. This is kind of typical of what we see. We'll look at some fuel control alone, which is a perfect test we have recorded. Take a look at this one. The response is perfect, but don't expect every sensor to be this good. You should use Mode 6 data as a guide and verify the results with a snap test. So when you have a pattern that may not be perfect, don't panic. Remember, rely on the Mode 6 information to tell you how close you are to a failure and let that be your guide.